Hello everyone. I'm happy to talk here. My name is Nozomi Kurihara. I am a software engineer at Yahoo Japan Corporation. I'm sorry this talk is totally pre-recorded because the time is early in the morning in Japan. Anyway, today I will talk about use cases in Yahoo Japan, especially focus on our current use case, large-scale log pipeline. The takeaway of my talk is why Yahoo Japan uses Pulsar, how Yahoo Japan uses Pulsar, and what benefits we received by using Pulsar. By the way, I guess you are very tired because this session is the last of 2 days, but I hope you enjoyed the last session and there will be something informative for you. Okay, let's start my talk. The title is Large-Scale Log Pipeline Using Apache Pulsar. First, please let me introduce myself briefly. Again, my name is Nozomi Kurihara, and I am a software engineer at Yahoo Japan. I have been working on an internal messaging platform using Apache Pulsar in our company for about 3.5 years, and also I am a committer of Apache Pulsar. Anyway, let's see today's agenda. Today we have 2 sections. First, I will explain Apache Pulsar at Yahoo Japan, our motivation, performance test results, and use cases. Then I will talk about large-scale log pipeline, on which currently we are focusing. Okay, let's start the first section, Apache Pulsar at Yahoo Japan. First, I will explain the situation in Yahoo Japan. Yahoo Japan is one of the biggest portal sites in Japan. This is the top page of Yahoo Japan. I'll show the 3 numbers which represents how big Yahoo Japan is. Okay, we've got 3 numbers. What are they? Okay, I'll tell you. The first one is the number of services in Yahoo Japan. Yahoo Japan has a lot of services like auction, shopping, news, etc. And that number keeps growing. The second one is the number of servers. Note that they are all real, not virtual. In order to handle 100 plus services, more than 150,000 real servers are running 24 hours a day. The third one is the number of login users per month. This is an average value in 2019 June. It implies that there are so many customers visiting our site. As you can see, Yahoo Japan is a huge site. Yahoo Japan has used Pulsar for about 3.5 years. We use Pulsar as a centralized messaging platform. In other words, there is a single Pulsar and a lot of services use it as a tenant. So there is a Pulsar team, including me, and they are maintaining Pulsar. There are many service streams such as auction, shopping, and mail, and they are using the same single Pulsar as tenant. Next, I will explain about our users. Today we have more than 270 tenants and 4,400 topics. There are over 50k publishes and 150k consumers per second. And typical use cases are notification, job queuing, and log pipeline. Let me briefly introduce Pulsar promotion in Japan. We have held meetup events in Tokyo 4 times so far. These meetups include hands-on and use case talks. We have talked in other communities such as JJAG, Japan Java User Group, which is the largest Java community in Japan. and Kafka Meetup Japan, in which we talked about comparison Kafka with Pulsar. And currently, we write some blog posts in Yahoo Japan's tech blogs, which introduces Pulsar's architecture and client libraries. Let me move on to the next section. I will explain why Pulsar was chosen in our company. Why did Yahoo Japan choose Pulsar? Because there are several requirements. First, there is a large number of customers. We need to handle a large amount of messages and ever-increasing number of customers. Then high performance and scalability is required. Second, there are 100 plus services. In this situation, providing each service-specific messaging platform is expensive. Then multi-tenancy, in other words, multi-tenant platform where all services can reside, is helpful to reduce the maintenance costs. Third, sometimes messages can be sensitive or mission critical. In such situations, loss of message is not acceptable, and resending is often required. Then security and durability is important. Lastly, there are multiple data centers, and users want to replicate messages to remote data centers. Then georeplication is required. At the first time we started to develop our internal messaging platform, we have searched and investigated some candidates, such as Apache Kafka, and finally we adopted Pulsar because Pulsar meets all requirements at higher level than Kafka. Of course, though, Kafka has been keeping evolving, and currently more and more new messaging platforms are appeared. In my feeling, Pulsar's multi-tenancy and georeplication are still the most useful of all. Let me talk about Pulsar's multi-tenancy a bit more. Multi-tenancy means multiple services can share one Pulsar system. Before introducing Pulsar, each service has own messaging platforms. In other words, they have to prepare servers and maintain the system. That is clearly extra burden for service engineers. On the other hand, after introducing Pulsar, each service and application can just use Pulsar as a tenant, so they do not need to maintain their own messaging system anymore, and can concentrate on their service logic. As a result, a lot of services can work on only one Pulsar system, and then we can reduce hardware and labor costs. That is quite important, particularly in a lot of multi-services situation like our company. Another advantage of Pulsar's multi-tenancy is self-service. Users can create, configure, or delete their namespaces and topics by themselves. So Pulsar maintenance do not necessarily know detailed settings of all tenants. Moreover, we use a web UI tool to manage tenants. Through UI, users can create tenant namespace and configure their settings by themselves. And users can see topic stats, for example, average message size, throughput, and subscriptions. Thus, the management of each tenant is delegated to each user. This is important, particularly in the case where there are many tenants. Note that recently Web UI tool called Pulsar Manager is open sourced and actively developing. We are also planning to replace our internal tool. This tool is internal, Yahoo Japan only, but we are planning replace it with Pulsar Manager. Next, I will explain our architecture and performance test result. This is a simple illustration of system architecture in Yahoo Japan. We have two clusters. One is west, another is east. In each cluster, we have brokers, bookies, zookeepers, and WebSocket proxy servers. Also, we enable geo-replication, so messages are replicated across clusters. Next, I will show our performance testing. These are our experimental settings. Here, our Pulsar version is 2.3.2 for broker side and 2.4.1 for client side. Message size is 1 kilobyte. We changes number of partition 1, 16, and 32. Also, we changes rate 100,000 and 100,000. Here are server specs for our broker and bookies. Note that Bookie have SSD for journals and HDD for ledgers. These graphs show the experimental results. The left graph shows achieved rate and the right graph shows latency. For 100,000 cases, each partition achieves 100,000 rate and latency looks fine. On the other hand, for 500,000 cases, the achieved rate with one partition is about 200,000 and latency gets worse, these yellow lines. But partition 16 or 32 achieves 500,000 with lower latencies. We have tried a couple of experiments and finally concluded that our cluster has enough capacity for now, and current bottleneck is network. In other words, 10 Gbps NIC. Next, I will show a tuning example. Currently, we saw more and more users start to use internal Pulsar. As users increases, SSD writes increases. That causes heavy load on SSD and reduces its lifespan. Indeed, we saw frequent failure of SSD. To solve this problem, we carefully looked Bookie's configuration and finally found that channel max group weight msec is important. This parameter controls the frequency of channel writes. We increased it from 1 to 2, and then number of writes dramatically decreased by about 30% at the sacrifice of the least latency. That expands our SSD's lifespan. Let me move on to the next section. Next, I will explain use cases in Yahoo Japan so far. The first example is notification of contents update. The situation is that various contents files, for example weather, map, and news data, are pushed from partner companies to Yahoo Japan. Services want to know the update of these contents. First, services subscribe specific Pulsar topic. When contents are updated, notification messages is sent to the topic. Then services receive a notification and then they fetch the contents from file server. Like this, you can use Apache Pulsar as notification transferring system. The second use case is job queuing in Yahoo Mail. What we want to do is indexing of mails. The problem is that it can be heavy sometimes. so we want to do it asynchronously. First, if a main backend server receives a job request, it registers the job to Pulsar topic. Another server takes the job from the topic and processes it. And if the job fails, it will be re-registered to the topic. Like this, you can use Apache Pulsar as asynchronous job queuing system. Next, I will explain a story of migration from Kafka and how easy it was. At Yahoo Japan, we have an internal fast system using Apache OpenWhisk, where Apache OpenWhisk is composed of some components, including Apache Kafka. Here I omit the detail of the system, but the problem is the first team had to maintain all of the components, especially Apache Kafka. They wanted to reduce their maintenance costs, so they decided to migrate from Kafka to our internal centralized Pulsar. The migration is done by using Pulsar Kafka wrapper, which is compatible with Kafka client. Note that they didn't need any code changes except some configuration. Therefore, the migration was done very quickly, indeed within a month. So if you are considering migration from Kafka to Pulsar, don't worry, it's very easy. Let me move on to the next section. So far, I introduced our existing use cases. Next, I will explain our new use cases, large-scale log pipeline. First, let me introduce our situation. Currently, in Yahoo Japan, almost service applications are running on PaaS, Platform as a Service, like Pivotal Cloud Foundry, or CaaS, Container as a Service like Kubernetes. Any service developers deploy their apps on PaaS or CaaS, then it's natural requirement to monitor their apps. In our company, we have some monitoring platforms such as Splunk or Yamas, where Splunk is a log searching platform, I think you know, and Yamas is monitoring platform like Grafana. I introduce the detail of Yamas later. What we want to do is to send application logs and metrics to monitoring platforms so that service developers can monitor their apps. Here I will briefly introduce Yamas. Yamas is a SaaS-type metrics monitoring and alerting platform. It was born in Verizon Media and recently Yahoo Japan starts to use. Note that it will be open sourced soon. Next, I explain how large the scale is. 15,000 applications are running on 75 containers on PaaS. The amount of total log is 1.4 to 3.8 terabytes per hour. Therefore, peak network traffics are over 10 Gbps order. Also, we expect number of platforms will increase more and more. Next, I will explain the architecture. This is the legacy architecture. In this architecture, agent library is installed in computing platforms. For example, PaaS has Splunk agent and also Yamas agent. There are these drawbacks. First, computing PES need to install dedicated agents for each monitoring PES. Then specific knowledge for each agent is required, and troubleshooting is complicated. Second, scalability. In our implementation, we run an extra component where agents are running and it is legacy, not scalable system. so scale-out is complicated and difficult. Third, traffics. Since this architecture is tightly coupling, traffic spikes directly influence monitoring PFs, or if monitoring PFs are down, computing PFs cannot send data, instead buffering data, and it degrades their performance. As I showed in the previous slide, our legacy architecture has some problems. To solve this issue, we started new project, including computing PF chains, monitoring PF chains, and Pulsar chain. Our goal is here. First, remove dedicated agent for no more specific knowledge extra component complicated troubleshooting. Second, decouple sender and receiver of logs and metrics for scalability and resiliency. This is a new architecture using Pulsar. Instead of agents, computing PS have Pulsar producer and monitoring PS have consumers. There are these advantages. First, agents are not needed anymore. Then computing PS can send data for all monitoring PS with single unified library. Second, we can easily scale out since the architecture is now very simple and no more extra components. Finally, traffic spikes are mitigated by Pulsar layer. Even if traffic burst happens, messages are buffered in Pulsar queue and sent to consumers with moderate dispatch rate. Next, I will explain the topic design. I think there are three patterns. First one is producer-centric pattern. In this architecture, topics are created for each producer. The advantage is that producers don't need to care about consumers. Instead, just publish their data to their own topics. On the other hand, the disadvantage is that consumers need to care about producers. In other words, consumers need to be aware of Pulsar's topics increases and responsible for filtering and transforming data. Second is consumer-centric pattern. In this architecture, topics are created for each consumer. The advantage is that consumers don't need to care about producers. Instead, just receive data from their own topics. On the other hand, the disadvantage is that producers need to care about consumers. In other words, producers need to aware of consumers' topic increase and responsible for transforming and distributing data for each consumer. Third is function pattern. In this architecture, topics are created for each producer and consumer. The advantage is that both producers and consumers don't need to care about each other, and data transformation or filtering is executed in Pulsar function layer. That is intuitive and logically concise. However, there are disadvantages on resource side. Since we have more topics than above two cases, traffic, computing, and storage costs increase. We discussed which pattern is better and finally chose consumer-centric pattern because there is a requirement that producer PFs controls the destination consumer PFs for each message. So consumer-centric pattern in which producers just choose the destination topic is suitable. And also we want to start with the minimal architecture first. So function pattern is too expensive for now, but of course possible option in the future where more producer PFs and consumer PFs are running. This illustrates our topic format. Tenant corresponds to consumer PF's names, such as Splunk, Yamas, etc. Namespace corresponds to regions, west or east. And topic name is composed of message type and number, where message type can be log or metric. And our message format is JSON like this. I will explain Yamas use case. To monitor all topics on Pulsar, broker stats are taken from Pulsar's admin API and sent to Yamas topic. Then Yamas consumers receives from the topic and store data on their system. Finally, any users on Pulsar can see Pulsar topic stats on Yamas dashboard like this. This is the current result of this log pipeline project. By introducing Pulsar, we can successfully decouple producer PFs and consumer PFs. And we can reduce operational and hardware costs, especially in producer side, since we need to extra sender components anymore. So the summary is, Pulsar plays an important role to connect various PFs and make whole system simple, scalable, and resilient. And these are future plans. We expect more and more PFs use this architecture. Also, we are planning to visualize SLI for example, message delivery rate and latency of the whole system. Thank you for listening so far. My presentation is almost done. Finally, I'll conclude today's talk in the next slide. In conclusion, first, I explain that Yahoo Japan uses Pulsar as a centralized platform for various services. Next, I introduced recently we start to use Pulsar as a large-scale log pipeline, where Computing PES publish their logs and metrics, and Monitoring PES consumes them. I explained that thanks to Pulsar, we can make the system simple, scalable, and resilient. Okay, my talk is all finished. Thank you for your time and interest. Bye.